Myself, Vaishnavi, Assistant Professor Information Technology from SNS College of Engineering. Now, I'm going to take the topic in the computer organization architecture, pipelining. So, before we are going to know about the pipeline, let us know how the processor will work without the pipelining. So, what is pipelining and superscalar? We're going to learn about that right now. So here we take the concept that there are employees working in a company. So without pipeline, a computer process get the first instruction from memory, performs the operation it calls for, and then goes to the next instruction from memory. So while fetching the instruction, the arithmetic part of the processor is idle. It must wait until it gets the next instruction from the processor. So it need to wait for a long time. So it can only perform one instruction at a time, because when the instruction comes, the fetch will work. After the fetch, the decode will work, and then it will execute. So in total, if it takes 30 minutes for fetch and 40 minutes for decode and 20 minutes for execution, in total it takes 90 minutes for the completion. So to avoid this, we go for pipelining. Pipelining is an implementation technique where multiple instructions overlap in execution. It divides the stages. Each stage complete a part of an instruction in parallel. The stages are connected to one to the next for a pipe. Instructions enter at one end. So progress through the stage and exit at other end. So it does not decrease the time for individual instruction execution, but instead the instruction throughput will be increased so that the pipeline is determined how often an instruction exits the pipeline, so that we can increase the throughput of the output. So pipelining divides an instruction into steps, like each step is executed in a different part of the processor. Multiple instructions can be in different phases each clock cycle. So fetch for instruction 1, if it is in fetch stage, then after fetch it will go to the decode stage in clock cycle 2, and instruction 2 will be in the fetch state. So there will not be any idle in this kind of operations. So what is superscalar? So it's similar to pipelining. The only difference is superscalar can perform multiple instructions at a single clock cycle with redundant facilities to execute an instructions. We are doing 3 iterations of the loop in 50 cycles, then it is 16.6 cycles per instructions. So hazards. Now we go into the hazards. What is hazard? A pipeline instructions that executes a hazards or situation that prevent the next instruction, the instruction stream, from executing during its designated clock cycle. So when the pipeline is stalled, it is said to be instruction hazards. So we have data hazards, instruction hazards, and structural hazards. So first, structural hazard. Structural hazards occur when a hardware resources has been requested by more than one instruction at a time. So at that time, the structural hazards will occur. So physical or hardware resources. So when there is enough hardware resources, the paint and brushes, the workers are holding. It is enough to support parallelism and there is no stalling. So it functions as the pipeline should execute. Structural hazard. When there is a lack of resources, it is not enough to support parallel execution of instruction and no new instruction can be fetched, stalling will occur. So if the resources is not enough, the structural hazards will be occurred. To reduce, it will reduce the performance. So to prevent, there should be always enough hardware resources. So next is the data hazard. So it will happen in the memory because data must be fetched from the memory. When the operation instructions will get all the existing data from the memory, the instruction will add the value and the existing data to the instruction before it is. So the current instruction to write to the memory. After it have write back to memory, it can now fetch data from memory. This continues so on and so forth. Data hazard. So when the first instruction read the data from memory, before the first instruction write back to the memory, the next instruction read the existing data in the memory, so the data will be in error. So when it reads the data after write back, there will be an overlap error. To overcome this, control hazard is when fetch that it does not know outcome of an earlier branch. So what does it happen before? So the branch instructions executed first until the other instructions will be keep waited. So current instructions will be dropped and the branch instructions will be executed. So it will give priority to the instruction of the branch instruction. Once it is done, then it will be moved to the next instructions. So here the workers will give priority to the branch instruction. Once the branch instruction is completed, then it regain with the original instructions.